Hi folks, my name's Ashley. I'm one of the founders of Skira, and in this video I'm going to show you how to get started coding games in TypeScript with Construct. If you want to use JavaScript instead, we do have a whole other video on that. There's going to be a link in the video description, but in this video I'll focus on TypeScript. Very briefly, what is TypeScript? TypeScript is essentially an extension of JavaScript that adds types. So normally JavaScript is a dynamic language and you don't have to give anything a type, and with TypeScript you annotate everything with particular data types, and this helps you get your code right the first time round, as it adds lots of extra checks, and it helps with things like autocomplete, which I'll show later on in this video. It's a very popular alternative to JavaScript, and you can use it to code games in Construct as well. Now, to demonstrate this, I've got a sample project here which is based on the Spellcaster code example, but it's really stripped down to just a minimal amount of code, so I don't have too much code to work with in this video. I'll just show you how it works very briefly. It's got the player here, who's this wizard character, and I can move them around using the arrow keys, and they also look at the mouse cursor. And it's just a small amount of code. You can see there's main.js and utilities.js, and that's the entirety of main.js, and this is the entirety of utilities.js. So that's just a small amount of sample code to work with in this video. Now, I'm going to skip over installing TypeScript. It's covered in the documentation, so refer to that if you want help with that. It just amounts to installing Node.js and then TypeScript, and then using an external code editor. I'll be using VS Code. So, first of all, an important step is to use a folder-based project. So that's the option in Construct to save your project to a folder of separate files. And here's the one I'm working with on the desktop. And in the scripts folder, you can find the two script files that are in the project here. Now, to start with, I'm going to open VS Code and show how to use it to edit JavaScript code as an external editor. So this is a sort of step before we then move on to using TypeScript. So here's VS Code, Visual Studio Code, which I've got installed here. It's a really great editor. We use it to develop Construct itself, and it's also written in TypeScript and uses the Chromium browser engine itself as well. So that shows what's possible with using these technologies. So I'm using VS Code to open just the scripts folder in the project folder that I'm working with in Construct. And here we can see the code that I had in Construct. Now, when you're using an external editor, there's one really important setting to set in Construct. And if you go to the scripts folder here and right click on it and tick auto reload all on preview. And what that means when it's enabled is every time I click preview in Construct here, then it will go back to the files in the project folder, reload them, and then preview using the latest version of those files. So that sets up a nice workflow where I can change a file inside VS Code, click preview in Construct, and it will show the difference straight away. So now I'll just demonstrate this workflow by writing a small bit of JavaScript code, and this will also help demonstrate the difference to how the workflow is when using TypeScript. So what I'm going to do is just write a line of code to change the player's blend mode to additive. That will make them look sort of a bit transparent. This is just to demonstrate the workflow, so it's a bit of sample code. And if you pay attention to how autocomplete looks as I start to write code, you can see VS Code here is trying to suggest things, but it's suggesting things that aren't properties in this object, such as the move player function down here, as well as things which are, like add event listener, and it's also missing out things like I want to use the blend mode property, but it doesn't appear in this list. And the reason for that is partly because JavaScript is a dynamic language, so VS Code can't tell what properties this object necessarily has, and also VS Code doesn't know about all the APIs, all the functions and properties available in Construct's APIs. So you have to just know which property to use, which is blend mode when using JavaScript, and I'm going to set it to additive, and I can save that file and then click preview in Construct, and it immediately updates. So that shows the workflow, how it's automatically loading that file from the project folder. Now you can see it looks slightly semi-transparent because that's the additive blend mode. Normally it's used for things like explosions and other kinds of lighting effects. I'm just using it as a piece of sample code for the purposes of this video. And also to demonstrate how error handling works in JavaScript, suppose I make a mistake and there's a typo there and that's spelt incorrectly. And if I preview the project, what happens is I'll just see a blank screen and I won't know what the error is until I open the browser developer tools, and you can see the error is logged here, invalid blend mode, because I've spelt the additive blend mode wrong, and so that's not allowed as a blend mode. Of course I can fix that and put it back, and then it will work again. So with JavaScript you often don't find out about errors until you try to preview the project and it tries to execute that code. TypeScript helps with that. Now I'm just going to put back the code to how I had it at the start, and then I'll move on to demonstrating how that works with TypeScript. So we can see the player with the normal blend mode again. So now let's switch this project over to using TypeScript and show how that all works differently and much better because it can catch all these kinds of errors for us and help with autocomplete. So to do that, you right click on the scripts folder in the project bar, and in the TypeScript menu choose Setup TypeScript. You only need to do this once. It'll work for a bit and then tell you that it's finished. And I'll show you what that does. In the project folder here, there's three main changes it's made. First of all, it's added the tsconfig file, that's the configuration for TypeScript. It's added a folder called tsdefs. Now this is TypeScript definition files, which covers all the information about constructs, APIs, and also details about your particular project that you're working with. And lastly, it creates a .ts, that's a TypeScript file, for every JS file in your project. So that gives you a TypeScript file to work with instead of the JavaScript file. Now, switching back to VS Code, what we want to do is switch to our TypeScript files, and then we'll set up a workflow where as we write TypeScript code, when we press save, it will automatically compile to JavaScript, and then when we preview and construct, that will show the difference again. To do that, in VS Code, you hold Control, Shift and B, and then you choose the watch option. Now what that does is it will automatically watch for changes to your TypeScript files and automatically compile them to JavaScript. Now you may notice that as I've set this up, TypeScript has started to identify some errors in these TypeScript files. The reason for that is TypeScript requires type annotations for all the variables and parameters of functions. And this is very much how TypeScript is able to help you write your code. It's because it requires these type annotations, which is why when they're missing, it highlights it as an error. So I'm just going to close this, and I'm going to go through and I'm going to add type annotations to fix those errors. So in this video, I won't go through all of TypeScript's syntax. They've got lots of documentation on that. But the basic syntax for a type annotation is a colon and then the type after it. In construct, the type of the runtime object is iRuntime, and you can find all the names of all the classes construct uses in the documentation. One of the nice touches about TypeScript and VS Code is when you hover the mouse over a type like that, it gives you a little tooltip which describes it, and there's a link straight to our documentation where you can find a reference on that class and how to use it. So I'm now going to continue going through the code, the TypeScript code, and adding type annotations, and that will fix these errors that TypeScript is reporting. And here delta time, that's a number, so I use the number type to annotate that. Now here we have some slightly different errors. Here it's saying that player_inst is possibly null, and in short the reason for that is getFirstInstance can return null if there are no instances in the project. In this case we know that our project always does have an instance of the player object, so we know it won't be null. TypeScript doesn't know it's not null though, which is why it's showing this error, because you can't access the X property of something that could be null. So TypeScript has an easy way to deal with this type of problem. If you add the exclamation mark operator as a suffix to the end of an expression, then that tells TypeScript it's definitely not null, so don't worry about that case. And you can see the error has now gone away because it knows that it's not null. And we need to do the same thing for these references to the keyboard and the mouse for the same reason, because they may be null if those objects aren't added to the project. Now you can see there are no more errors in this file, and I'll just switch to the utilities file and do the same thing. This time these parameters are numbers, so I'll add the number annotation to all of them, because without any annotation, theoretically it could operate on anything at all, so you just have to say that it's a number to tell TypeScript that. Here, this method is slightly different. I want this method, which checks if an instance is outside the layout, to be able to work with any kind of object which can be placed in the layout, and then construct that's of type world instance. Now, if I save that file, I've now fixed all of the TypeScript errors. So now I've successfully upgraded this JavaScript code into TypeScript. Now, to demonstrate the workflow with TypeScript and some of its benefits, I'm going to do what I did before and set the player instance blend mode. Now, here I've got some code to get the player instance, and as before, I'm just going to add the exclamation mark, and that will tell TypeScript that player instance is definitely not null. Now, as I start to write the code and I type the dot, this autocomplete is now a comprehensive list of every property and method available on this object. So it's not missing anything out, and it's also not including anything that I can't use correctly here. So this is a really useful tool to help you when you're writing your code. And you can see it's got the blend mode property now, so I can just click on that and it fills it in for me. And another great thing about TypeScript is all our type annotations for construct. They include things like the valid values you can use for properties and functions. So here, when I just type the opening quote of the string to assign, it's suggesting for me all the valid strings I can assign for the blend mode as well, and it's listing additive there for me. So I can simply fill that in without having to remember how to spell it or what the option name is or anything like that. And when I press save, that automatically compiles it to JavaScript, and you can see the line of code's been added there. It doesn't keep the formatting, but it doesn't matter. And then when I switch back into construct and press preview, it's now reloaded that JavaScript file and the player's appearing with the additive blend mode again. So there we have it. That helps you write your code much more easily and with lots of error checking to help. Just to demonstrate that error checking, if I suppose I spell the additive blend mode incorrectly as I did before, now instead of having to preview the project and wonder why I'm getting a blank screen, TypeScript has already identified that this is an error, and it could do that thanks to the type definitions. You can see here it's reporting that I can't assign that string to that property, and it's even suggesting which one I meant, so it's got the correct spelling there. So that's just an example of how helpful TypeScript can be to make sure you get your code right the first time. Now, to show how TypeScript helps you write your code in your project, I'm just going to go a bit further and write some more code for this project. I'll just delete that because I don't need it anymore. What I'm going to do is, if I go back to the project here, you can see there's a sort of fiery spell here, and I'm going to make the player fire that out from their hand when you click the mouse button, and I'm going to do that all in TypeScript. And one thing to note is the player sprite here has an image point at the end of their hand here, so I'll make sure that the spell fire thing appears from their hand in this location instead of the origin, which is the default, which wouldn't look right. So to do that, let's get coding. I'm going to do some live coding here on this video, so hopefully I get my code right. First of all, I'm going to add a function for when the mouse is clicked. Let's call it on mouse down, and I'll need a reference to the runtime with the type iRuntime, and the event object, which, as with doing normal JavaScript coding, is going to be a mouse event. And now I'll set up an event listener to make sure that is called. So before the project starts, I'm going to add another event listener to the runtime, and another great part of TypeScript here is when I type in the string for the event name, it's also auto-completing, suggesting all the possible event names that I can use here. So again, it's similar benefits to the blend mode string before. So I can choose mouse down and use a callback to call the on mouse down function, which I just wrote below, and pass along the runtime and the event object. So now this function is called whenever any mouse button is pressed. And I am only interested in the left mouse button, so what I can do is check if the button is not 0, which is the left mouse button, then I'll just return from that method. So now when I click the mouse button, I want to create that spell object and I want it to appear by the player's hand. So first of all, I can get the image point of the position of that image point by the player's hand. So let's get the player instance again, and you can see as I type in the object names, it auto completes everything. And I'm going to add an exclamation mark again because I know that's not null. And I'm going to use just a little bit of destructuring here to get that image point. So get image point, that's this method, it's auto completing for me. And image point 1 is the one which was by their hand because 0 is the origin. Now I want to create a spell instance at that location. So again, I can use runtime.objects.spell. So I can choose that from the list and create instance. I want to create that on layer 0. You can see the tooltip appearing there with tips about the parameters to pass, and that's going to be the X and Y coordinate that I identified above. One more detail to set up is that I want the spell to set its angle to the same as the player. Now I can save that. There are no TypeScript errors, so I'm fairly confident that code is correct. And if I preview the project, it's now loaded that code, and when I click the left mouse button, you can see the spell object is created by the wizard's hand. So that's working nicely. You can see they don't fly forward, so let's make that work. So what I'm going to do is in the tick method, I'm going to go through every single spell instance and move it forwards. So to iterate every spell instance, I'm going to do for spell inst of spell instances. So this is using a generator function to iterate every instance of the spell object type, and then I'm going to offset its x coordinate if my math is as I remember it. It's the cos of the angle, and I'm going to move that at 600 pixels per second, which means 600 times dt. And then also the same thing on the y-axis, but with the sine of the angle and at the same speed. And again, save, preview and construct, and there we have it. The player is now firing spells, casting them, if you will, from their hand, and you can see them all flying out. So that's getting TypeScript to help me write my code correctly and make that all work. Now there's one small bug in this, if you will. These spell objects that fly out, nothing destroys them, so they just fly on forever. So it's sort of a memory leak, and what we want to do is destroy them when they leave the layout so that they free up the memory. So you can see the object count here, the more I click, the more that's just going up because they're flying off the screen forever. Let's stop that from happening. So let's switch back to our TypeScript code, and now what I want to do is use this utility method isOutsideLayout, and if the spell goes outside the layout, then it will destroy it. And you can see that that is imported up here using an import, so I can access those methods through utils. So let's use that, and again TypeScript can autocomplete that for me with those available utility methods, isOutsideLayout, and I'll pass the spell instance, And if it is, I'll destroy it. And let's check that in construct again. Oh, I'll just use the debugger so you can see the object count. And now, even if I click super fast and keep an eye on the object count, you can see that it's destroying those objects as they go outside the layout. So there we have it. That's a demonstration of how you can use TypeScript to help you develop your games with really great autocomplete, good error detection, and so on. So just to finish up this video, what I'm going to do now is just demonstrate some of the tools that TypeScript gives you, which can be really helpful to you when working on your code, particularly in large projects when you have a lot of code that you're working with. So first of all, you can go to the definition of functions. So suppose I have this method here and I think, where is that function actually defined? You can right click on it and choose go to definition. And TypeScript, VS Code and TypeScript are able to take you directly to where that function is defined. Even if there are multiple things using the same name, it can get the right one because it uses the static typing system to precisely identify which function that is. You can also do this the other way around. If I right click on this function here and choose find all references, it will then list in the sidebar here a reference to every single place that is used in your code base. Obviously there's only 2 here, but if you imagine working with a large project with hundreds of references, this can be a really useful tool. And lastly, based on a similar system, you can easily rename things. So suppose I want to rename this. Normally with JavaScript you might have to go through your entire code base and rename a whole bunch of things, but if I just type in a name for that and press enter, then TypeScript has automatically updated the name of that for me there. If I refresh that, you can see it's updated there as well. So that's also really useful for larger projects. You don't have to go hunting for every reference to your project. It can just automatically rename things. Obviously there's only one reference there, but if you have hundreds, it can precisely and correctly update everything for you. So that's just a brief summary of how TypeScript works in Construct, how its coding abilities can help you with autocomplete and error detection, and set up a nice workflow to be able to work conveniently with an external editor like VS Code and Construct. There's lots more to learn, so you can learn more about TypeScript itself. You can see some more examples in Construct. We have our entire command and construct example game system with thousands of lines of code all written in TypeScript, which you can check out as an example. And there'll be lots more resources and documentation linked to in the video description, so have a look at those. Give it a go. We hope you enjoy using TypeScript in Construct, and thanks for listening.